Hey, greetings and welcome, friends. Taking a look at last night's quest on page 314, talking about imaginary complex numbers, things like that. We're going to hit more on that today. If you hear someone laughing, that's just my son Everett. He's hanging out with us today, doing some math. So problem 6 was the square root of negative 64. Now, prior to our knowledge of imaginary numbers, you would have said, that's not possible because, right, 4 times 4 is positive 64, or negative 4 times negative 4 is positive 64. However, this negative part we can actually break up into the square root of negative 1 multiplied by the square root of 64. And the square root of 64 we know is 8. And the square root of negative 1, we recently, newly just defined I to equal the square root of negative 1. And I is the imaginary unit. Alright, so 8I is the answer to that question. Alright, and it's a positive 8I. That minus sign was accounted for in the I there. Alright, so that's our first glimpse at that, problem 6. Now problem 8 is a little bit trickier. We're multiplying two imaginary numbers. So what I'm going to do is multiply the coefficients of them, so to speak. 4 times negative 3 is negative 12, and I times I, as you might suspect, is I squared. Now, if I is equal to the square root of negative 1, well, if I square both sides of that, I will end up with I squared is equal to, and the square root cancel out, and I get I squared is equal to negative 1. That's actually going to be something we'll have to memorize. We'll work on that in today's lesson as well. So I squared is equal to negative 1, so I can replace I squared with that. And negative 12 times negative 1 is going to be positive 12. Right? So not too bad once we understand the concept of this substitution here. Problem 21 requires some properties of radicals. So I've got the square root of a quotient, so I can actually break that up top and bottom. So that's the square root of negative 4 over the square root of 9. And hey, let's also just break that up into the square root of negative 1 times the square root of 4 times the square root of 9. And I can now evaluate all of these. Square root of 4 is 2, square root of negative 1 is I, and square root of 9 is 3. So I could write that as 2I over 3. That's also the same as 2/3 I, depending on which one you want. Either is correct, though. Right? So that's not too bad. So let's look at one more problem. Get that written all the way over here and up top. Where we're now just fully combining our concepts of imaginary numbers, the I value, the imaginary unit, with our properties of radicals and such. So let's just break this all apart into things that are factorable. So the square root of negative 1, I can take that minus sign out. The square root of 36 is factorable. Square root of m squared squared. I guess I could, yeah, I'll do it like that. M squared squared is the same as m to the 4th, and the square root of n squared I've got here. So let's see, square root of 36 is 6, square root of negative 1 is I. Just so you, maybe you've noticed at this point, is that I've been writing my numerals in front of the I. That's the same as if I had like a pi or something like that showing up. I would still write a number in front of it, even though I and pi do represent numbers themselves. Square root of m squared squared, or the square root of m to the 4th, is going to be m squared, and because the index is even and the exponent was even, absolute value would show up. And the square root of n squared is absolute value of n, right? Because even index, even exponent, that shows up as well. Let's see, get those equal signs going in here. So this can simplify to 6i. M squared no longer needs absolute value because an even exponent would make anything negative positive anyway, and n to the 1st would still need its absolute value, so abs n would still be necessary. Actually, I'm not sure if the book had the absolute value of n at this point, but I figured we could throw it in there for now anyway. Sometimes by this point in the chapter, they just assume that all variables are non-negative. So there's 24. So thanks for watching, friends. Hope that all made sense to you. We're going to do some more work with imaginary numbers in today's lesson. So take care. Bye-bye.